tried to learn all these types of chemical bonds, but you failed? Guess what? You are not the only ones. So let's try to learn it in a different way with the kind help of these gentlemen. Chemical bonds are interactions between electrons from the valence shells of two or more atoms. It is like the most external electrons circulating around the nucleus, they somehow do interact with each other. Bonds are created because atoms aim to decrease energy levels and to gain stable configuration. So let's compare it to the real life. You and your girlfriend live in your hometown, going to universities, you both have credits and both pay rents for different places to live. And as a result, you lose a lot of money. Money, money, money. So what can you do to lower your costs? You can start to live together. You can pay one rent, cook together, and after all, your cost of life will decrease. Actually, only her cost of life decrease. Yours stay on the same level for the whole time. Sorry. Most atoms strive to have 2 or 8 electrons on their outer shells. 8, this is an electron octet. If you've got something in common with music, you can associate that to an octave where you also have 8 sounds. So, we've got many different types of bonds, from which the most basic one is covalent bond. When you think of this type of bond, you should always think about pair of electrons. This pair becomes common for both atoms, and one electron in a pair comes from one atom and the other from another atom. If this bonding occurs between atoms of the same element, only then electrons are shared equally by these atoms. We can call this situation an unpolarized bond. An unpolarized bond. An unpolarized bond. If we have different elements, electrons will be moved towards atom of higher electronegativity and higher number of valence electrons. We can call this situation polarized bonds. We can highlight at least 2 types of covalent bonds that can be useful in future chemistry learning. Sigma, when electrons are shared because orbitals of atoms overlap axially, and pi, when electrons are shared because orbitals of atoms overlap sidewise, independently of atoms' axis. Do you believe in magic? Coordinative bond. This is the type of covalent bond when we still have a pair of common electrons, but both electrons in this pair come only from one element. Atom which gives electrons to be available is a donor, and atom which takes them to fill its valence shell is an acceptor. How to remember this? Coordinative bond, coordination, coordination, blood donation. Blood from a donor goes to acceptor, and donor does not lose anything by donating his blood. An acceptor can fulfill his own supplies. Keep an eye on it. Ionic bond has much in common with electronegativity. If 2 atoms have extreme values of electronegativity, then you can assume that this is an ionic bond. And again, the stronger atom that takes electrons from the other one is the one with higher electronegativity. Ionic bond provides us ions as an outcome and not a molecule. And actually this is an electrostatic interaction between ions. So, if you think about ionic bond, you should always think about crystals of good solubility in water. Nope, not these crystals, just salt. Yay! Not a bond for a blonde. Sometimes blonde hair may turn green in the swimming pool where the water is chlorinated. This may be the result of interactions between positively charged copper ions and negatively charged hair. And nothing else matters. Metallic bonds. You should have no problems with remembering how these bonds work. Let's check the main instrument of Metallica band, electric guitar. The strings are most often made of steel-nickel alloys, sometimes covered with anti-corrosive polymer. The final properties of metal strings are based on the fact that metallic bonding is quite plastic. We have here only ions of metals, specifically cations, which are ions that lost their electrons and have deficiency of electrons and in consequence are positively charged. These ions are surrounded by these free delocalized electrons that are called electron gas or electron glue, which might help you associate this with the fact that strings are so elastic. So in fact, the metallic bonding is an electrostatic interaction between cations and electrons. One more example. Cations may be metallic band members and delocalized electrons may be the crowd of fans that surrounds these sable guys. Hydrogen bond. This is one of the weakest type of chemical bonds and it is based on hydrogen. It occurs when a hydrogen that is bound to some highly electronegative atom, for example an oxygen, is at the same time attracted by some other nearby highly electronegative atom. In real life, it happens quite often. A guy has a beautiful wife and is bound to her by the institution of marriage. She is beautiful and let's compare this to high electronegativity. However, suddenly the equally beautiful next door neighbor attracts a guy to create, we have a cheater, hydrogen, that already married wants to have a new experience. This is how you can define hydrogen bonds. Van der Waals interactions. They can be definitely found in noble gases like argon, xenon or in helium. You can associate them with this man, who was the discoverer of these interactions. His name might already sound quite noble-ish, so quick association can be made to noble gases. Well, that's all for today. Thank you for your attention and I hope to see you soon. Yay!